Right. Welcome, the genius. Yes. Welcome to your day one of an interesting journey. Okay, this is something that is going to be very, very interesting. This journey that you have started today, the decision that you have made to take this route is going to really pay off because tech is the way forward. Computer programming, software development, artificial intelligence, cybersecurity, blockchain, name them, cloud computing. This is the way the world is going towards now. Okay. So it is a very good decision that you have made to be part of this program. Okay. So this is a couple of 12 months program that you'll be learning the basics of computer science, tech, computer programming, web development. And at the end of the whole day, you'll be building a website. You build a website for your dad's company. You could build a website for your uncle's company. But at the end of this program, you're going to build a website. So, but we have to start from the scratch. Okay, we are talking about computer. We are here to learn more about computer programming, but we need to understand the history of computer. All right. If somebody wants to tell you something about your family, they need to tell you the history of your family. So you need to understand where your great grandfathers, what they have done to get to your father and to get to you. So you need to understand. Let's understand the great grandparents of computer. The modern computer we have now, the mobile phone that you're using, the laptop that you're using, the desktop, even the calculator. Okay, let's understand what has actually transpired before the pre-era of this machine that we are using today. So let's dive in. Okay, so before computer, we need to understand the need for calculation in early civilization. Basically, this computer that you're using today, the main drive, the reason why it was built or it was developed, it is because of there was need for calculations. All right, there was need for calculation in early days, in this early civilization, counting stones, tally sticks, and abacus. So these are the methods that we've been using to count. Our great grandparents, they were using stones to count. All right, but these days now you can now use your calculator. You can even use your computer to do some calculations. So but you need to understand that there was need for calculation. So what were the early tools used? One was abacus. It was used in China over 2000 years ago. The one is Napier's bones. Okay, it was developed in 1617 by John Napier's multiplication tool. So the developer was John Napier. We also have the slide rule. It was invented in 1600 for engineers. Okay, so all these things were developed because there was need for calculation. Even the computer that you're using today, basically what your computer does is calculation. The basic thing that your computer does is calculation. You're watching a movie, you're listening to a music. What is happening under the hood or behind the scene under the computer is basically calculations. So we are going to be learning how these things work. Okay. So the concept of algorithms before computer, we'll also be taking a look at them here. Okay. So the pre-computer era. So let's take a look at before machines, what was happening. So what is the meaning of when we say pre-computer era? What do we mean? Okay, when we are talking about this class is about the pre-computer era. So what do we mean by that? It refers to the long period in human history before invention of modern computers. So we are looking back. Today, you're using modern computers, your laptop, your mobile phone, all right, your television, okay? So these are modern computers. But we are trying to look before then what happened. A long period ago in the human history, before the invention of modern computers, what really happened? That's what we are looking at. So in this time, people still needed to perform calculations, just like you're performing calculations today. You want to do the logarithm of a number, you use your calculator. You want to do all sorts of calculations, you use your calculator or your computer. So before then, people still needed to perform calculations. They still needed to store information. Remember, your computer also stores information. But before computer was created, what were people using? there was still need for calculations. There were need for storing information. And there were also need to solve problems. That's the most important thing. All right. What our computer does today is solving problems. Artificial intelligence is solving problems. Okay, your calculator is solving problem. Your Python code is solving problem. So there was still need for all these things, but they had no electronic machine. They were nothing like electronic machine. The computer that you're using today is an electronic machine. Your telephone, your calculator, these are electronic machines. But those days, they were nothing like electronic machines. But there was still need to perform calculations. There was still need to store information. They were need to solve problems. How were they able to do it? They relied on their own mental skills, manual tools, and simple mechanical devices. They were not, of course, there were no electronic machines, so they developed mechanical devices. Today, we are using electronic machines like our computer, our calculator, all right? But those days, they were nothing like electronic machines. So they developed mechanical devices using their mental skills and manual tools and simple mechanical devices. So this is how they were solving problems those days, all right? Interestingly, the word computer originally referred to a person. So those days, a computer is someone whose job was to do calculations. Do you understand? So this computer that we are using today to refer to an electronic machine like your laptop or your phone, it was referred to a person whose job was to do calculations in those days. You understand? So a computer, before computers were introduced or developed, was someone whose job was to do calculations. So these humans that we call computers, whose job was to do calculations, they worked in fields like astronomy, navigation, engineering, trade, and government. So you can see that all these kind of fields, astronomy, navigation, engineering, they existed before computers were developed. But then in these fields, astronomy, they need to do some calculations. They need to store some information. When they are doing navigation, they need to do some calculation. They need to store some information. So how were they doing it? They were relying on their mental skills. They created some manual tools. We'll be talking about them soon. And then they also created some mechanical devices. So let's take a look at the timeline and historical context. The pre-computer era spans thousands of years. What we are talking about now is these thousands of years, starting from the ancient civilizations and lasting up to the mid-20th century when electronic computers began to appear. So electronic computer began to appear in the 1930s, 1940s. All right. So these were when electronic computers started to appear. These were when they started creating electronic computers. Okay. Some key historical changes. Ancient times, people use basic counting methods like their fingers. Our forefathers, they were using their fingers and stones to count things and sticks. You can even remember, even as a kid, we also use stones to count something. I remember using stones to count. I remember using what's it called? Bottle covers to also count. We even count with our fingers. Do you understand? I believe you have also done something like that. So calculations have to be done. Then they could use their fingers to count, they could use their stones to count. So these were those days. We still use it even till today. Some people still use their hand to count. All right. So during the early civilization, tools like the abacus and the tally marks were used to trade and keep record. So abacus and tally marks, they were used to trade, perform some calculations in trading, and also keep record. During the medieval period, devices like Astrolabe helped in navigation and astronomy. So Astrolabe is the tool that was used to do calculations in navigation and astronomy. The tool is called Astrolabe. So it was used in navigation and astronomy. So in the 18th century, mechanical calculators started coming up, like the Pascal's calculator and the Napier's bones were developed in the 18th century. You can see the progression. Ancient days, we were using fingers and stones, sticks. During the early civilization, abacus and tally marks were used to trade and keep records. Devices like astrolabe were created in the medieval period to help in navigation and astronomy. Then mechanical calculators were now introduced in 18th century. So Pascal calculator and Napier stone bones were developed. So in the 19th century, more advanced calculating machines like the Babbage difference engine emerged, but they were not yet electronic. This Babbage difference engine was better than the previous Pascal's calculators and the Napier's bones, but they were still mechanical. They were not yet electronic. Okay. Then we have tools like abacus. This is one of the earliest counting devices. So abacus was used to count, and it was invented in the ancient times. Okay, and it was later improved in China. So abacus was used in doing some calculations, counting device. It was a counting device, all right, and it was invented in the ancient time, but it was later improved in China. So abacus. All right. So abacus used beats sliding on rods to perform addition. Now, the thing is that we are not going to go into details of how abacus works because that's not our focus. But we are telling you this so that you can understand that the computer that you're using today, the reason why it was created is to solve problems, do some calculations and solve problems. So as you're coming into the computer field, all right, you need to understand that your job is to solve problems. Do you understand? This journey that you have started today, the reason why computers were created was to solve problems. So you're a problem solver. Okay, so that's what we need to understand. Previously, before the era of computer, how were our forefathers able to cope in calculations and solving problems, storing information? How were they able to cope? One of these tools they created in the 18th century was the abacus, and abacus uses beads. They will put the beads on rods. Do you understand? So these beads are put on rods, and they use these beads to perform addition, subtraction, and multiplication and division. So, like I said, I'm not going to go into details how it works. There will be no need for that because we are not going to be using it. But you need to understand how they were using manual devices to perform this kind of calculations. So we also have the tally sticks and counting boards. The tally sticks was a simple tool for recording numbers. So when it comes to keeping records, all right, when it comes to storing or keeping track of debts and trade items, the tally sticks and the counting boards were used. So in terms of keeping records, recording numbers and storing information, the tally sticks and the counting boards were used. When it comes to performing addition, subtraction, and multiplication, the abacus was used. Okay? But today, all these things that can be done by a computer, both storing information and storing data can be done by the computer. Doing addition, all these things can now be done by the computer. So we also have the Napier's bones. It was invented by John Napier to simplify multiplication, division, and square roots. So this might be an upgrade on the abacus. So it used rods. Remember, the abacus used beads on top of rods to do multiplication and division and addition. But the Napier's bone used rocks marked with numbers to help with calculations. Abacus used beads on top of rods to perform calculations. But the Napier's bone used rods that are marked with numbers. These rods are marked with numbers to help with calculation. We also have the slide rule, which was invented in 1620. The Napier's bone was in 1617. Okay. This slide rule is based on logarithms, and it was invented by William Oughtred. Okay, I don't know if I pronounced it well, but it was based on logarithm. So the slide rule was used for more advanced calculations like logarithms. So it used multiplication, division, roots, logarithms, and trigonometry. So you can see how the thing we are upgrading. Abacus was used for primary multiplication, division, and addition. Napier's bone came on to simplify how multiplication and division was done. Then the slide rule came to do something like logarithms, roots, square roots, trigonometry, and stuff like that. So you can see how they were progressing. So anytime they develop a device, they will look at a way of improving that device. All right. And that is how computer has been evolving. That is how computer has been evolving. So we also have the astrolabe, which in ancient days, it was used for navigation and measuring star positions and telling time. So the astrolabe was a device that was used to perform, it was used in navigation. So they use it to measure the positions of stars and telling time. So they use it to perform stars, measuring for stars position and telling time. So we also have the Pascal calculator, which was in 1942. Pascal calculator was created in 1942. It was invented by Blaise Pascal to help his father with task calculation. So apparently his father was a task calculator. So he now created a Pascal calculator to help his father. So one day you're going to help your father create a software that would help his company. At least by the end of this program, you'll be creating a website for your dad or your mom. Okay? All right. So the Pascal calculator could add and subtract automatically using gears and wheels. So you can see that these devices have different things they use. The Pascal calculator uses gears and wheels. The Napier's bones uses rods that are marked with numbers. Then the abacus uses beads on top of rods to perform calculations. So don't worry, you don't have to cram all these things. You don't have to cram them. We just want to give you a perspective of how computer has really evolved. So then we also have the Babbage difference engine in 1822. It was designed by Charles Babbage. I know most of you know this name. So it was a mechanical device to perform mathematical tables automatically. So you can see things were evolving. Things were evolving. It was considered a step towards the modern computer, even though it was never fully built in his lifetime. So this was never fully built in his lifetime because of finance. So he didn't complete the building of the Babbage difference engine. But this is really considered a step towards the modern computer. So that's why Charles Babbage is referred to as the father of computer. So because his work really gave a very big step towards the modern computer. So before machines, large teams of trained mathematicians worked as human computers. Remember, a computer is someone who performs calculation. So they calculated astronomical data, navigation charts, engineering plans, and financial accounts. So this was the role of humans before computers. So the human computers, those people we call computers, whose job was to perform calculations, they were trained to perform some mathematical operations. So they calculate astronomical data, navigation charts, engineering, and stuff like that. So government, the military, and the research institutions employed them for accuracy. So you see, those days they were employing human beings for computations, for calculations. They were the people who were called computers because they were good at doing calculations. But these days, computers are the real computer that we now know are now used to do all these things. So characteristics of the pre-computer era, there was no electricity. So there was nothing like electronic device. There was no electricity. All calculations were manual or mechanical. The speed and accuracy depended heavily on the human skill. But you can see our computers today can calculate something in milliseconds, in nanoseconds. Okay, tools were often portable and require training to use. So they have to be trained. All right, you have to train these human computers. So invention and innovation were driven by trade, navigation, science, and engineering needs. So before the era of computer, these are the things that really the characteristics of that period. Okay, so what are the limitations? Calculations were very slow. Manual calculations can take hours or days, but the computer today can do it in seconds, in milliseconds. All right. Their calculations were error prone. Mistakes were very common without double checking. But today, your computer is very, very accurate. Okay. There were limited storage, no way to store huge amounts of data like modern computers. So you can see that today, our computers are better because they have evolved. They have been growing from time to time. And today, they can store large amounts of data. But those days, the pre-computer era, they could not store large amount of store. Remember the sticks and the cutting device we are used to store, so they could not store a lot. Complex tasks, advanced scientific problems were extremely hard to solve without mistakes, but today computers can do them efficiently. So what's the importance? So this era is crucial because why are we teaching you this thing? It laid the foundation of modern computing. You cannot do without your great great grandparents because they are the people who gave birth to your parents and they gave birth to you. So there's no way you can write them off. So this pre-computer era introduced concepts of data processing, calculation, and problem solving. Okay, it inspired inventors to design faster, more accurate tools. So this provided the mechanical and mathematical principles later used in digital computers. So you can see the role that this pre-computer era has actually played. They really did a good job. Okay. So in summary, the abacus was a tool and device that was used for basic arithmetic. It was developed and used mainly by the ancient China, all right, and the Sumerians. The tally sticks were the inventors were vendors, so they were used in record keeping and counting, so storing data. The Napier's bone was developed by John Napier. Multiplication and division were made simpler. The slide rule was used for more mathematical calculations like logarithm, trigonometry, and stuff like that. The astrolabe was created by the ancient Greeks and the Arabs. So it was used in navigation and astronomy. Pascal's calculator was created by Blaise Pascal. It was used for addition and subtraction. The difference engine was created by Charles Babbage. This is where mathematical tables and operations were not done automatically. Okay, so let's take a look at the abacus. Okay, the abacus is one of the oldest known calculating device in human history. So it is simple. It's a simple manual tool used to perform arithmetic operations such as addition, subtraction, multiplication, and division. So the abacus really played a very big role. The Chinese use this very well. That was over 2,000 years ago. So what's the origin? Counting boards and bit-based calculators existed before the abacus. So we have things like counting boards and bit-based calculators. So they were using bits to do their calculations. Okay, so now the Chinese Suapan developed around the second century. Okay, so the Chinese abacus design influenced other countries such as Japan and Korea. All right. So basically, despite modern calculators, till today, some people still use the abacus in the Asian region. Okay. So what kind of operations it performed? It did addition. Okay. The bits are moved towards the beam to represent adding numbers. So there's a way they actually do it. It did subtraction. It did multiplication. It did division, square roots, and cube roots. All right. All right, so what was the advantage? There was no power needed, so it works without electricity or batteries. They were durable, they can last for decades. They were portable, lightweight, and easy to carry around. Educational, so the abacus improves concentration, memory, and number sense when it comes to educational. So they were fast. Skilled users can perform calculations faster than using a calculator for certain problems. So the abacus was it played a very big part, a very big role. So what was the limitations? It requires training and practice to use effectively. So with the abacus, you need to be trained. Okay, some people still use it till today. So it cannot store information for later use. But our computers today can store information for later use. But with the abacus, it cannot store information for later use. But computer today can perform all these operations and still store. So it was less efficient for extremely large or complex calculations. So you can see most of these devices created those days, they had some limitations, and that is why they created our computers today. So what is the importance in history? It helped traders to do their trading, merchants and tax collectors to keep records accurately. It supported scientific, engineering, and navigational calculations before modern tools like the computers we use today. They served as a stepping stone towards modern computing. So abacus is one of the great grandparents of our modern computers today. Okay, so big respect to the abacus. So, in interesting fact, in China, abacus training was often part of primary education until the late 20th century. So, they still teach people in primary education. Abacus users develop the ability to perform calculations mentally by visualizing the abacus. So, it is a skill called mental abacus. So, they can just visualize mentally and do their calculations. So, it was a very good skill. World record abacus speed calculations are still held by students from Asia. So the Asians are the people who use this abacus very well. They use it very well. Okay. So what are the Napier's bones that was created by John Napier's? So it is a manual calculating device invented in 1617 by the Scottish mathematician. So John Napier was a Scottish mathematician. The reason why he developed the Napier's bone is to simplify multiplication, division, and extraction of square roots. Okay, so it was one of the earliest mechanical aids for calculation before modern calculators and computers. So you can see that everything that we have been talking about here has to do with calculations. And that is what the computer is also all about. Our computer today, basically what it does is calculations, storing information, manipulating that data. All right, remember, computer is you give it data, it processes the data and give you the result. That's what the computer does. So the device used a set of rods. So for the Napier's bone, they use a set of rods that are marked with multiplication tables to speed up arithmetic. So they use rods. Meanwhile, the abacus use beads. All right. So John Napier was born in 1550. He was famous for inventing logarithms, creating Napier's bones. So that is why he also created the Napier's bone to solve logarithm, trigonometry, and stuff like that. So he helped contributing to early calculating methods. Napier's work greatly influenced the development of mechanical calculators and logarithm tables. So we cannot throw away his work. Advantages of the Napier's bone: it was much faster than the traditional long multiplication. So basically, it was faster than the abacus. Easy to learn with basic training, but the abacus was hard to learn. There was no memorization, so there was no need to memorize full multiplication tables. It was just easy to use. It was small enough to be carried around, and limitations: it requires manual addition and subtraction. So it was still manual. But today our computer is automatic. It was not as fast as later mathematical calculators that were developed, so it was lagging behind. It was limited to the range of numbers shown on the rods. So there is a limit to what you can calculate. Physical handling of rods could lead to errors if misplaced. Okay? So if you misplaced the rows, it could lead to errors. So why was it important? It was considered as a stepping stone towards mechanical calculators. It influenced designs of later devices like the slide rule and Babbage engines. Demonstrated the use of positional number systems. Just like I said, you don't need to cram all these things. Sure, basically, you don't even need to remember all these things, but you need to understand, okay, what really happened before the computers today that we are working with. The name bones came from the original use of animal bones for the rods. So originally, they were using animal bones for the rods to do the calculation. So Napier died the same year he introduced the device. Wow. So after introducing the device in 1617, he also died that same year. Wow. Modern replicas of Napier's bone are still used in educational settings to teach multiplication visually. Okay. Now, the last one we'll talk about is the slide rule. The slide rule, sorry. The slide rule is a mechanical analog device used for calculations. Everything was mechanical, but it was now more of, they were advanced coming up. So this time around, we could do logarithms, rules, and trigonometry with the slide rule. So it was invented in 1600, and it became the essential calculating tool for scientists, engineers, and navigators for over 300 years. So you can see before these computers actually came on board, these are the things people were using. So slide rule is one of them. It is often called the computer of engineers. So those days, engineers were using the slide rule to do a lot of things when it comes to their job. So it was created in 1614. So let's take a look at the origin and history. So since 1614, John Napier invented inverse logarithm. Then after inventing logarithms, he introduced the concept that multiplication can be turned into addition. So that's that logarithm. So in 1620, English mathematician Edmund Gunter develops a single logarithm scale used with a divider for calculation. So in 1632 to 1633, William Alfred, an English clergyman and mathematician, invented the slide rule by placing two logarithm scales side by side and making one slide past the other. So you can see how these guys, so there's no way we can talk about computers and we don't recognize the work that these guys have done. So over the years, engineers refined the design into multiple types, such as linear, circular, and cylindrical slide rules. So this is the job that these guys have done. So we just need to acknowledge it. So there will be no need going to how the slide rule works because we are not going to use it, of course. But you can do more of your research if you want to. So it was used for multiplication, division, square root, logarithm, all this kind of the sine, cosine stuff that you do in your mathematics. So the slide rule was created to make it easier for humans to calculate. So there are different types of slide rules: the linear, the circular, and the cylindrical slide rule. Like I said, all these things you don't need to remember them, of course, but it's just to give you the perspective, for you to understand how far computers have gone, how they have been transformed, how they have evolved from simply performing calculations, solving problems. So those days there were problems. Traders needed to keep record of what they are doing. They need to make some calculations. So these engineers, astronomers, these are the things they needed to. They needed tools that could help them in their jobs, and that is why they created all these devices that do calculations. And this is how computers were invented. They were created out of all the jobs that these people have also done. So advantage of the slide rule: it is fast, it's very quick, it's quicker than the longhand calculation, it is portable to carry around, it handles a variety of math and engineering tasks. So the slide rule was a very big upgrade. Okay, it was without batteries or electricity, but of course, it has some limitations. No exact answer. The results are approximate. So the results of the slide rule they were approximate, so they were not exact. It requires training. It needs practice to use effectively. It was limited to certain functions, so it cannot handle modern large data computing that we have now. So what's the importance in history? It was used in designing bridges, airplanes, and spacecraft. Can you imagine? Can you imagine? So it really played a very big role. It was critical to engineering feats like the Apollo space missions, the NASA engineer. So it did a really good job. It did a really good job, okay? So interesting facts. No, it was known as the symbol of the engineer. And then in the mid-20th century, pilots used specialized flight slide rules for navigation and fuel calculation. So you can see that they use the slide rules for making navigation. That's the pilots. But today, they are now using computers to make it easier for them. So the decline started in 1970 with the rise of electronic calculators. So when in 1970, electronic calculators started coming, so the need for the slide rule started fading. Okay, so thank you very much. I hope you enjoyed this small story that I've just told you. This is just to give you an understanding of how far computers have come. And then in the next class, we'll be seeing more of the history of computers. So thank you very much. Please, if you have any question, reach out to us. Reach out to us. We're always available. Do your test and we'll see you in the next class.